Is it visible?
Yes.
And the PPT is visible, right?
Yes.
Okay. So, yeah. Good morning. My name is Yashrat Samke Patel. Like I said before, my industry experience has been of 5 years. First former 2 years were in identity and access management. Second were in later years were in information security. So like this case study Atul just showed, so the part where my part of identity and access management is to take care of the accesses, was to take make user profiles and check their accesses, maintain the basically role based accesses of users. So if something would have happened, it was my responsibility, or it would have been my responsibility to check that this certain user was not there before, this was not the access that was given before, and that was the first step of identification that something is wrong in that attack. And the second what you say information security is related to firewalls and cloud security. So the part where the person accesses a particular file or breaches the firewall and gets into certain resources that he's not supposed to. So that is taken care of by the information security role. Okay. So today we'll have an introduction to the client server model. So this is a networking model. Okay, our entire internet is based upon this client server model. Then we have UDP echo server example. So again, this is an example of the client server architecture. I will show you the communication that happens between the two. What is time and date service? Okay, yes, so this is time and date service on your physical PC as well as the protocol NTP, network time protocol. Then I'll give you an overview of sequential and concurrent servers. So this is based on the idea of sequential and concurrent programming. Okay, so based on that concept, based on that programming, these servers are set up. Then what is broadcasting requests and alternatives to the client server architecture. Okay. So by the end of this entire session, you'll get to know what is client server model of interaction. Broadcasting is a part of this, so that is why I haven't mentioned here, but overall you'll get an idea, a complete idea of what the client server is. Till now, okay, introduction to OSI model. I guess this Priyanshu has
Yes.
taught you all of this. So basically, I'll just ask basic questions of, to get an idea of where we stand. So what are the OSI model layers? Can anyone tell me?
There are 7 layers. So we
Mm-hmm.
start with physical layer, then
Yes.
we have data link layer,
Mm-hmm.
then network layer, transport layer, session layer, application.
We missed the presentation between
Presentation.
Presentation. Yes.
Yeah, presentation layer and application layer. Yeah.
Yes. And nowadays, like in the model layer, the functionality remains the same, but we have combined the presentation and session layer. Okay.
Yeah.
So, yeah. So it was more of like these layers have very just a few functionalities. So nowadays people, have combined those two and just refer the first three and the last application layer.
So
Okay.
basically, we have been taught about TCP layer where we have 4 layers
Ah,
as mentioned, or otherwise 5 layers.
yes. Yes. So internet protocol IPv4, I think this was with that NAT and all. last
Yeah.
session. Application, check reputation. Yeah, good. We have seen to usage. Submitting my address. Yeah, ARP. Okay. So ARP, ARP is also an example of this broadcasting request.
Yeah.
Yeah. So in just, can someone give me a brief of ARP?
Yeah, sorry about.
So basically, ARP stands for Address Resolution Protocol. Okay, and
Mm-hmm.
what it does is basically it maps the IPv4 to the physical machine, which is basically the MAC address of the machine. So it will be easy
Correct.
for the it will be easy for any system to go out in the internet with an IP address, or basically public IP address, and it will get the information back to the private IP address which is within the network. So that is the basic,
Yes.
the
Right.
use. Yeah, thank you.
Correct. Yeah. So absolutely correct. So that data link layer needs an MAC address to send data. So when we say that we connect to some server or some other machine, we only have the IP address. We don't know the MAC address. And in order to get that MAC address so that the data can go through that layer and that connection can happen, ARP is used so that we can get that MAC address out. DNS, domain name server. Okay. So I'm sure you all know, but domain name server is that server which holds the domain and the IP table. So when I say that I want facebook.com, the first thing my PC does is obviously he'll check his cache, but if that is not there, he'll connect to the DNS server. He checks the IP that is associated with it. He sends it back to me, and my browser then goes to that Facebook web server so that I can get the login page, right? Pretty simple. DHCP. Okay. Again, anyone, any idea of DHCP? Just one sentence is fine, so that we can just recap of what is taught.
Yeah, so dynamic host configuration protocol. So generally it works on DORA, and then try to allocate the IP address to the system
Correct.
to
That's it.
establish the connection. Yeah.
Yeah. NAT. I think this was the last session, so probably it's fresh in everyone's mind. Just a brief of NAT. Anyone? Okay. So I'll just say it in one sentence. So NAT is something. NAT is a protocol that we use when a machine with a private address or a machine in an internal network wants to access something that is on the public internet. Okay, basic, simple. So let's say this is my machine. Okay, this is the connection out on the internet. This is a router over here, and I want to access something that is on the internet. Okay, so whatever my private IP address is, okay,
Yes, sorry to interrupt.
and
Are you showing something on that whiteboard?
yes, not
But
visible.
not visible.
Okay, wait. Let me check. I'll share the entire screen. Okay. Now,
Yes,
Yes.
it is. Yeah.
okay. So, so the basic let's say formula is that something with a private address is not able to connect with something with a public address. Okay, like very overview or very simplistic definition you can say. So what I have to do now, I have to convert this private IP into a public IP. So who does that? Your router will do that for you. So he will take this IP address, convert it into something public, pick anything 142 something something, and use this IP to connect to Facebook. Then Facebook will send the login page. It will come back to 142, this IP. This is the NAT of 10. So the router knows that I have to send this login page to this computer. I'm saying this because there can be multiple computers. So your router knows that 142 is the NAT of 10, and I have to send whatever information is sent by Facebook back to the main requested computer. Okay, that's an overview of NATing. So generally what happens is sometimes we get firewall requests, okay, where they say that so in an industry, in company, it is restricted environment, right? So not everything is allowed. So when someone says that, hey, I need to connect to Facebook because I want to research something, so that time this comes in place. And generally for outgoing connections, generally it is allowed, but the problem comes when something from outside is coming in. Okay, that time the restrictions are high. So what happens is generally it is no problem for internal network to connect outside. That is fine. It establishes the connection. But when Facebook wants to send the login page back to the server, that time he cannot send it because he, as in the Facebook server, has a public IP, and the computer that it is sending to has a private IP, which is not allowed. So that time this private will be converted to public, and he will connect to the public IP address, not the private. That is the only way that Facebook will be able to send data to the private computer, uh, computer with the private address. So that is NAT. And this scenario, I'm specifically saying for industry related environment. Okay. You are able to see the PPT right now. Now, I mean, you can see both now, the whiteboard and the PPT, right? Okay. Next lecture, I mean, after this session, we're going to learn about the socket API. Okay. So coming to client network architecture. Okay. Just give me a sec, guys. My battery is low. Just a minute. Sorry for the delay. Yes. So by the name, the client server architecture, what do you think it would be?
So
What do you think the name suggests?
it's a communication between client and server machine.
Yes. Okay. So there is let's assume that there is two people that are talking with each other. One is a client, one is called a client, one is called a server. Okay. I mean, the name itself suggests what kind of architecture this is going to be. Okay. Little, what do you say, scientific definition. A client and a server networking model is a model in which computers such as servers provide the network services to other computers such as clients to perform a user-based task. this model is known as client server model. Okay, so in this, a client is basically a mobile phone, a laptop, personal PC, okay, anything that can make requests to a server. And in server is it can also be a PC or software, a piece of hardware that provides networking services to the other computers. Okay, can anyone give me any example of any networking service? Anyone? Or rather any service that a server provides? Do you think this is a network server service? Is this a network service provided by the server that I'm using, this whiteboard?
Yeah, it's running on cloud, so you are requesting or doing something there, which is being responded back, and you are able to get the response.
Yes, correct. As simple as that. So I am on my PC, sitting on my PC, okay, and I am requesting this board. I am requesting, sending a request to Microsoft. Okay, this whiteboard.microsoft.com, whiteboard.microsoft.com, to provide me this page that you see, to provide me this interface that you see. Okay, so here I am the client. Okay, my personal PC is the client. I make a request to the server that please provide me this whiteboard so that I can draw, teach, whatever I want to do. That is the basic architecture, that is the basic concept. An entire internet is based on our client server architecture. So we all are clients over here, and there are servers out on the internet which provide services. Okay, this, the connection is also going through the internet, and these servers are also on the internet. Okay, if let's say there was no internet in between, okay, so there is an office. Okay, this is an office building A, and there is an office building B. Okay, I am sitting here and I want something from office B, so I send a request and I get it back. Okay, there is no internet in between, just probably physical lines, physical wires. Okay, can I still call it a client server architecture?
Yes.
Good. Okay, so it doesn't matter what the medium of communication is, as long as there is someone who's requesting and there is someone who's providing, it is qualified as a client server architecture.
Before internet comes into picture, mostly all the applications what we were using, we used to deploy on the servers within the office, and different clients were requesting those services from that one.
Yeah, absolutely correct. So before, this is what is called on-prem,
Yeah.
and nowadays on cloud. Okay, but they all follow the same thing only.
Yeah.
They all follow client server architecture only.
Yeah, but then like earlier we used to follow two tier. Nowadays we are following three tier, right? So where application is residing on one server, a database is on another server, and then client as we are requesting it from different machine, and then client, application server and database are communicating to each other separately based on the client request.
Yes. So this, there can be many scenarios, like now this is my PC, this is a server, this is one server. So client, okay, then server 1, server 2. So it can happen that something that I need is on server 2. Okay, and this is just a, what you say, for security purposes or a way to get here in industry.
Mhm.
So this
Mhm.
can be called as a terminal server.
Yeah.
So in this server there is no what you say, processing that is done. Okay, there can be functions or applications running on it and you can get data, but it won't process anything. Like it won't generate a report of your subnet or your other network devices or applications. So in this case what I say that 192.168.0.1 connect to here. So I will connect here. Again over here, I will say connect to 172.142.0.1. This will take me to server 2. And then over here, I will do whatever I want because everything is on this server. Here I can say, I can develop an application, a Java application. I can access YouTube. I can say generate a report, whatever it is. Okay, and then directly back to the client. Next. So an application program is known as a client program running on the local machine that requests for a service for an application program known as a server program running on the remote machine. Like I said, so in this client server architecture, not necessarily that the server is going to be the physical hardware of a server like you see in data centers. It's just racks and racks of hardware. It can also be a PC on the other side, like how you have in at your side. So this is PC1, this is PC2. So the software on my PC connects to software on the other PC to get services that it needs. Okay, not necessary. So when I say server request, it can provide it hardware services also, like providing its own memory, providing its own processing power so that it can perform functions on it. Right. On the other hand, so I don't need this time in this request in the PC1 to PC2 request. I do not need any of the hardware services or the hardware power. All I need is the software application features. Okay, all I need is to see a video. All I need is to write a code. All I need is the result of that code. Okay, that is what I mean when I say that a application program is known as a client program, or an application program running on a local machine requests for a service from an application running on the server machine. Not necessary that it will always be a hardware service. Okay, it can be both hardware service and software service.
So just one quick question. In this case, even RDP, can we call it as a remote, client server model?
Yes, yes. So in this sorry, this example, so I am RDPing into this first server, right?
Yeah.
Yeah. So RDP is also based on the client server architecture. RDP is a software that will be over here
Yes.
on my client, right? So in this case, it is the software client that is connecting to the server.
Yeah.
Okay. Now when I connect, generally 90% of the time I'm going to use some software over here. Okay,
Yeah.
rest 10% it can be that I want to use this server's hardware properties. I want to use its memory, I want to use its software. This happens in cases of VMs. When I connect to a VM or I create a VM, that time it will go on the server and it will use the memory, the CPU, the processing power of the server. Okay, but that those are very few cases. Generally, it's all software only. So
I
yes,
see.
And
RDP is also client server architecture.
Sir, but I beg to differ here, Yashraj sir, but I don't
Yeah,
think
yes.
so. RDP is a software for that matter. I believe it's a tool or probably a protocol in order to access some of these access some of these services which are there on the end machines, right? I don't call it
Yes,
as a
RDP.
software for that matter.
Okay, RDP client that is RDP client that is installed over here when you set up that you want to use
Hmm.
port 3389 and then you want to send
Correct.
requests out that time that software I am saying yes, and RDP is a protocol.
Exactly, but I will not call it as a software for that matter, right? I mean, software is something else. You cannot call RDP as a software. See, basically, what I'm trying to portray is 3389 is a port, okay, and over that port, RDP is a protocol which is running in order to access the softwares which are there on the server side. And client is something who's basically wants to consume those particular services. This is how I look at RDP or remote desktop protocol for that matter, right? I mean, this is my understanding.
Okay, okay, I understand. Yeah, it's right. So I mean, you are right, obviously. I'm considering your the client. I don't know
Mm-hmm.
how I should put it. Mm, okay, let me see. Yeah, okay. So I am considering this client to this software client to be making a connection to the server. That is why the client server, the software client and the software server, like that I'm saying.
yeah,
Okay.
and again, when it comes to distributed system, again, probably it can be a complicated understanding if I'm a client machine and my hardware is being part of distributed system also, processing power or hardware. And for that matter, like if I'm considering a case of MongoDB or some documentation database where my hardware is being used as part of it, and as a client now I'm connecting to the database, and that is also communicating to my machine. So in that case, like what would be being it termed as?
So you mean to say my, as in the client resources will be used
Yes, yes,
for what? I mean, the MongoDB will be using my services
yes,
as
yes,
in my hardware.
yes.
No, so uh, the processing will be done on the server side only. It is not going to use your personal PC computing power.
No, I
So
guess that
once
the.
you
Mhm,
yeah, so once you connect, once a connection is made, right? So
mhm.
anything. So, so when I said that hardware resources will be used for so processing, it means that server processing power will be used. All you are doing is making a connection with the server. You are establishing, once your connection is established, anything that you want about it, you want to input data, output data, generate report, is all done on the server side only.
Yeah, but then that node, the server, it has one of the node as my machine itself, from where I'm initiating my request.
Hmm.
So I may be connecting to the server which is managing this, but still my machine is part of its distribution power, or maybe like database where it is being distributed. So it is being synced up with the other server. So probably, I means we can discuss about this later, but this is the actual
Yeah.
query coming to my mind, like how actually is it a client server or something else in that case?
Okay. Here I am assuming with your query is that you are saying that your client is also being used
Yeah.
up.
So I can configure document database to utilize my terminals as its processing power as well as storage power. But at the same time, I'm working from my client to access something on the server. And that server is having connection with my machine as well as one of the node for that database.
Okay. So you're talking about more of like peer-to-peer architecture where the
Yeah, means
server is not
distributed
defined.
database
Like,
system.
yeah, okay, okay. Something like Bluetooth, like both of them can be client as well as the server. Is that
Yes,
what
yes.
you're saying?
Yeah, probably sort of. I think
Yeah,
so.
yeah. Okay. So in this architecture, there is one dedicated server. Okay, that server cannot turn into a client. That server is
Okay.
not going to send requests. Okay.
Okay.
In the peer-to-peer architecture model, for example, our phone Bluetooths, where if I am sending you the files, I am the server, you are the client. If you are sending me the files, you are the server, I am the client. Goes both ways. Okay, I can be the client, I can be the server, you can be the client, you can be the server. In this
Mhm.
model, there is a dedicated server. The server is not going to send any requests to any other client. So if I am requesting something, that it is only going to provide, it is not going to ask me again for something.
Okay.
Yeah, server will not ask me for any uh, request to make data. Like when I say uh, Facebook to give me the login page, so that Facebook is not going to ask me about some other particular requests.
Yeah, but then situation here, what I was trying to discuss, application server where this request is going, that is fine in client server architecture, but internally to get that information, I need to access different database or one of the database, which can be a distributed database where I am one of the node.
Okay, okay,
And then now I'm requesting, but internally server may again come back to me to get some inputs and then distribute it back to me.
okay, okay, I understand. So you are a part of that network again.
Yes, yes.
Yeah, okay. I don't think that would fall under client
Client
server
server.
architecture. That would be peer to peer architecture or some other. Probably
Okay.
nowadays modern cloud queue client architectures are there. So probably
Okay.
somewhere under this.
Sure.
I get
Thank
your
you.
example, but I don't think that falls under client
Okay.
architecture. I'll have to research on this. Okay.
Yeah, yeah, sure.
I'll make, just give me a minute. I'll make a note down of this.
Yeah, mostly in smaller organizations, like I don't want
Mhm.
to spend most of the thing, and I would like to utilize my hardware for most of the things or
Mhm.
processing power. In such scenario, definitely I would consider a setup like this, and probably like that communication will happen accordingly.
Yeah, I understand. Like you want to make your client not only client but also
But
somewhere
yes,
in the database where it serves data and
yes.
computing power. Yeah. So most probably I'll research on this, but most probably this will not fall under client server architecture. This will most probably be under peer-to-peer architecture, where
Okay.
you can be both. Okay. In client server, there's a dedicated server. It does not
Mhm.
perform. It does not send requests for anything. It
Okay.
will only provide you services.
Sure.
Okay, it will only provide you softwares. It will only provide you processing power or memory. It will only provide reports generation if you want.
Mhm.
But I think it's a good question. Okay. So a client program runs only when it requests for a service from the server, while the server program runs all the time as it does not know when the service is required. So what I mean by that is, in this case, the server is always listening to the network. Okay, this is a server. Let's say these are different networks. Okay. So here servers have sockets, okay, which are always listening on the network. They are always listening on this network for communication requests. Okay, clients do not continuously send requests, nor are they continuously listening to the network. Okay, so over here this server is continuously listening to this network for communication. Only when one of them sends a request, it will accept the connection and give the client whatever it needs. Okay. So again, I would take an example of YouTube. So YouTube is continuously listening on the internet for whoever wants to connect to it. So, but only when a client makes a request, it will accept the connection and send him a video that is needed. Okay, a server provides a service for many clients, not just a single client. Therefore, we can say that client server follows the many-to-one relationship. Many clients can use the service of one server. Again, same model. So there are multiple clients in multiple networks. Okay, this is network 1, network 2, network 3. So many-to-one relationship where many is on the client side and the one relationship is on the server side. So one server has the capability of catering to multiple networks. Okay, it is listening to network 1, it is listening to network 2, it is listening to network 3. It continuously keeps listening to all the networks simultaneously, and only when one of the computers, one of the clients requests for a connection, it will accept that connection and provide whatever the client has asked for. Okay, so the examples are email, World Wide Web, etc. Like I said, the entire internet is based on this architecture of client server model. Okay, again, email is the same thing. You what do you say, I am sitting here and I want to send an email to PC2. Okay, the server that is going to come in the middle is the email server, and it is going to do the job of transferring the email from one to the other. So my request here is going to be that please send this mail to PC2. That is what my request is. So it is going to first the email server is going to keep listening. Okay, it continuously listens. Then I make a request that, hey, please send this mail to PC2. As soon as I send this, it will accept a connection. Okay, once the connection is set up, it will send this mail to PC2, and then PC2 receives, sends whatever. So in this case, as you see, there is no request made by the email server to PC2. Like I was saying before, this is a dedicated server. It is not going to make any request. It is not going to ask PC2 that, do you want this email? Should I send it? Should do you want me to do anything for it? No. All it is going to do is just going to send it. That's all. That's the only job of this dedicated server. So it accepts a connection, processes the request that where you have to send it, what you have to send, and just sends it. It does not accept any request. It does not accept any request of sorry, uh, make any request of whether I should send this mail to you, should I wait or anything. It just sends as soon as it receives the request of sending the email. Maybe I mean, this email example a little better to that explanation. I'll obviously search more, but for the time being, is it better clarity? Atul, I think you had asked that question, right?
Sorry.
Okay. Yeah, I was saying that distributed architecture, distributed where your client is one of the nodes in the database. That was your question, right?
Yeah.
Yeah. So I was saying, so I'll get you a better answer, but for the time being, is this email server example a little better? Where this is not making a request of whether I should send you the email or not, whether I should wait for 5 seconds and then send you, whether you want it at 12 p.m. or not. He just accepts and sends because it is a dedicated server and this is based on that client server architecture.
Yeah, but then in this case, email server is not having any sort of direct utilization of PC1 or PC2, right? It is just, it's on its own, it's a server. It is not a distributed thing.
Yes, that's what I'm saying. So in this architecture, he made a request. PC1
Yeah.
has already made a request to send. He has accepted it and he has done as he was told to do. There is
Yeah.
no request back from him, and or there is no request from him to like I said, when I should send, or do you want it after 5, or there is no request from server key, uh, can you check this for me, is this secure, is this properly sent, do you want me to send it in a particular what you say, particular path, do you want this email to go from this server 1, server 2 and then to PC. No such uh, request is made.
Only acknowledgement, probably if I'm requesting as a read receipt, then probably it may revert back to me, right? In that case.
Yeah. So distributed architecture of yours is going to be more complex, but client server basic is this way only. Like there is no uh, request back. There is no
Okay,
uh, asking of anything back.
sure.
Distributed architecture. So client server network advantages and disadvantages. Do you guys want 5 minutes break? Should we continue?
Anything fine. If you'd like to grab a tea or something, that is also fine.
Okay. Let's in 5 minutes. Okay.
Yeah,
12:30, 12:32 will meet. I'll just get some water. Okay.
sure.
Thank you guys.
Thank you.
Okay. Let's continue. Is everyone there?
Yes, sir.
Okay. 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 So this is mostly theoretical part. Okay. Uh, Client server network advantages and disadvantages. So let's start with advantages first. Centralized system with all the data in a single place. This is for the server, not the client. So the server is the centralized system and all the data is on the server. Cost efficient, requires less maintenance cost and data recovery as possible. The use of the dedicated server, again, I think I should have mentioned it before. Like I said, it's the dedicated servers. Okay, not a server that can become a client, not something like our phone. So the use of the dedicated server increases the speed of sharing resources. This increases the performance of the overall system. The capacity of the client and servers can be changed separately. So in this case, the capacity of not the function, but the capacity of what they can do, the capacity of requests that a client can make, the capacity of servers to serve those requests. Okay. Again, also the like I said, computing power. The servers can be configured to assign more memory or more CPU power to the client or the PC, laptop, mobile that is requesting those services. Okay. Uh, Anything? Is there anything that you have a doubt on these advantages?
No, that is fine.
Okay. Disadvantages. So when a large number of clients send requests to the same server, it can cause traffic congestion. Okay. So I'll get to it in the further slides, but there are two types of servers. One is sequential and concurrent. So as the name suggests, sequential is where uh, you know 1-to-1 ratio is there. Like one client can connect to the server at one time. Okay, only one request comes in, one request is served. In concurrent, multiple requests can come in, multiple requests can be served. So 5 PCs can connect to the server at one time, and that server has the ability to serve those 5 clients. So when generally what happens, even in concurrent, when a large number of clients send requests, the bandwidth that we have for serving can get congested. This is how these DDoS attacks happen. So what happens in a minute? Like the clients send thousands and thousands of requests, 10,000 requests at the time. So at the time, if the server has a capacity of handling only 250 requests, it gets overwhelmed and it stops functioning. Okay. So let's say I have one client, two client, three client. Okay. I also have VMs on these machines. Okay. Then I have some softwares on these machines. Okay. And each of them is making a request to the YouTube server to provide a certain video. Okay. Now this particular YouTube server has a capacity of handling 1,000 requests per minute, let's say. Okay. Let's say my physical main PC sends what do you say 100 requests. Okay. 100 tabs, 100 requests. That VM sends 500. This VM sends 600. Each of these softwares sends 100 requests, assuming that there are different clients logged into it. I am logged in over here, Priyanshu is logged in over here, then Atul is logged in over here, and everyone is making like at least 100 requests at a time. Okay, so this count goes beyond 1,000, which is the handling capacity of server. In this case, the server cannot serve all those requests, and it just stops. You get that buffering, then all the process go into deadlock situation where nothing works unless a particular process is finished first. So in this case, none of the requests is going to be served. It all comes to a standstill. Okay, and this is the basic principle of a DDoS attack as well. DDoS attack. Okay, so it's very important that you configure your server in such a way that you are able to handle these requests. Okay, you either increase its hardware capacity or you add multiple servers. Instead of one, you put 3 servers all having 1,000 requests per minute capacity, 3,000. Now this count is less than 3,000, so everyone will get to see whatever video they want. Okay, this is not going to cause any problems.
But in this
So
case, we may have to keep monitoring how many connections are being initialized, right? So if we are reaching up to threshold, then probably as a administrator, we may have to take certain actions to increase the number of connections.
So if not all are going to simultaneously start and end, some of these requests will end beforehand. Now if that happens, then a like a socket, or what you say, a connection is opened up, right? So
Hmm.
out of those thousands, I start at 12, someone starts at 12:01, someone starts at 12:02, someone ends in 30 seconds, this guy ends in half an hour. So something is going to open up, something is going to close, like that space you are going to have. So how are these designed? That if a case occurs where that timing is not matched, there is no more, none of the clients are disconnecting, everyone
Hmm.
is connected from half an hour, nobody is ready to go only. In
Hmm.
that case, then yes, an administrator will come in, he will either manually disconnect or increase the capacity, or add in this server to start up, backup server, secondary server to start up and start serving these requests.
Okay.
Yeah.
So in case of GPS, where we saw one of the clip in uh, LinkedIn recently, right? So many number of mobile connections are going, and then we see
Hmm.
that path is traffic jam.
Yeah.
So though it is not
Yeah.
a traffic jam, but because of connection, it is giving us a wrong interpretation that it is jammed.
There is no request to the server, no? There is no,
Yeah,
like Google keeps monitoring the number of devices. We have
yeah,
not asked Google anything.
okay.
Yeah. I think probably if all those had actually made a request to show them some path, then
Hmm.
that would have been a problem. But if there is no request for them, then it's fine.
Okay.
Okay. When the server is down, then the client request cannot be met. It's the same thing that I just said. Key, if it overwhelms, if it goes more than the limit, it will just stop sending. It will just stop accepting connections and giving you data. A client server network is very decisive. So another thing, that in these DDoS attack, an administrator comes in, okay, and he manually disconnects certain connections, okay, or he can, if the connections are legit, okay, in case of attack, he will just shut down the server or he will remove the connections manually. But in case they are legit, then he will probably increase the capacity or configuration. Okay, a
And
client server, yeah, yeah.
just one query, as this is seems to be a manual intervention. Are there like measures which can be also automized to get this done automatically, like automated script to do these activities?
Yeah. I don't have hands-on experience, but I have seen that you can log in to the consoles.
I
Okay.
can say.
And
Okay.
okay.
So actually, the thing was, one of my friend was working in Wipro, so he was handling the Skype for business project. Okay, तो उसमें कैसा था एग्जैक्टली आपका जो क्वेश्चन है ना, तो उनका स्काइप फॉर बिजनेस के ऑल ओवर वर्ल्ड में टोटल मेरे को जहाँ तक याद था उसमें 70 या 80 सर्वर पड़े हैं, ठीक है। तो वो स्काइप फॉर बिजनेस में कैसा होता था कि एक सर्वर के ऊपर जो ट्रैफिक ऑटो मतलब हैंडलिंग होता था वो था अराउंड 1,80,000, ठीक है, कॉल्स एक टाइम पे हैंडलिंग होती थी। तो ऑल ओवर वर्ल्ड उनका कैसा था, रीजन वाइज डिवाइडेड था। तो अब उस केस में कैसा होता था, एक एक लोकेशन पे जैसे पैक रीजन है तो उनके अराउंड 15 से 16 अगर सर्वर पड़े हैं, ठीक है। तो उस केस में कैसा होता है, एक की थ्रेशोल्ड सेटिंग थी, जैसे 1,80,000 के जैसे ही वो 1,80,000 टोटल कैपेसिटी थी और जैसे ही वो 1,20,000 क्रॉस करता था, ऑटोमेटिकली वो बैकअप सर्वर को ऑन कर देता है, ठीक है। और
Okay.
लोड बैलेंसर क्या होता था कि जैसे 1,20,000 तक उसकी हैंडलिंग कैपेसिटी 1,80,000 थी, लेकिन 1,020 के बाद ही अलर्ट चालू हो जाता था उसको, ठीक है, कि ये
Okay.
ट्रैफिक इंक्रीज हो रहा है। तो बस उसका इतना बस ऑटोमेशन, सारा कुछ ऑटोमेशन था, बस उसका इतना काम होता था कि 1,20,000 के जैसे ही ऊपर वाला एक भी आया, उसको दूसरे सर्वर पे अटैक रीजन में ट्रांसफर करना, ठीक है, पूल को, पूरे अगले वाले पूल को। तो ये सब ऑटोमेशन से होता था, बस वो मॉनिटरिंग चल, उनका मैनुअली इंटरवेंशन यहाँ पे क्या होता था, मॉनिटरिंग चालू रहता था सिर्फ, कि मतलब मॉनिटरिंग की। अभी कैसा होता था, ये भी कोई 1,20,000 है जो लेजिट है या नहीं, बस वो चेकिंग करना उनका मैनुअली काम था, क्योंकि मोस्टली वो
Okay.
लेजिट ही होते थे। बस वो कैसा है, ऑटोमेटिकली ये स्क्रिप्ट लिखी होती थी, जैसे ही 1,20,000 के ऊपर एक भी यूजर आया तो उस केस में कैसा होता था कि अगले पूल पे ट्रांसफर हो जाता था सर दूसरे पैक के, और वो कॉल उधर डाइवर्ट हो जाती थी, कॉल ड्रॉप नहीं होती थी, कॉल डाइवर्ट हो जाती थी नई वाली।
Okay.
तो इस वे से
Okay.
वो प्रॉपर वे से हैंडलिंग होता था उसका। तो मैंने वो देखा है पूरा स्काइप फॉर बिजनेस का जो पूरा कैसे काम होता था, तो उस केस में इसी वे में पूरा प्रॉपर सर्वर हैंडलिंग होता था, ठीक है।
So I guess what you told is just about load balancing, right? एक बार वो load identify हो गया तो it's balancing and sending it to the another server.
करेक्ट, करेक्ट, करेक्ट।
Correct.
Okay.
तो वो थ्रेशोल्ड सेट होता है जब हम लोग स्क्रिप्ट लिखते हैं ना, ऑटोमेटिकली उस केस में कैसा है कि लोड बैलेंसर का बस काम इतना है कि वो बैलेंस करता है,
हम्म।
ठीक है। तो जैसे उसको ज्यादा लोड आया, ऑटोमेटिकली दूसरे सर्वर पर राउट कर देता है ट्रैफिक को, ऐसे भी है।
और इसके बारे में एक सर ने जब चालू किया था, आई फॉरगॉट टू आस्क इन फ्लो, सर ने बोला कि ही इज वर्किंग इन आईएएम एंड दे यूज टू मॉनिटर इफ एनी users who are being created recently or like that, so if there is any fake account which is being created, so इसके लिए भी कुछ automation हो सकता है क्या कि like if there is new user added and then I'm getting a alert कि आज ये यूजर ऐड हो चुका है, तो you can verify whether it's a legitimate user or it's someone who is trying to hack something.
हाँ, तो कैसे होता है कि एक तो ऑनबोर्डिंग प्रोसेस में एचआर सारी डिटेल्स देता है, ठीक है। नहीं तो अगर कस्टमर होगा तो वो सारे डिटेल्स देता है। तो कभी कभी क्या होता है, जनरली जब अकाउंट बनाते हैं, ठीक है, तो जनरली सारी डिटेल्स पता रहती है, वो वेरीफाइड रहता है। एक तो कंपनी खुद करती है, नहीं तो थर्ड पार्टी होता है। प्रॉब्लम कब आता है, जब कोई लोकल अकाउंट रहता है, ठीक है, क्योंकि वो सारे एक डेटाबेस में नहीं रहते हैं। एक कंप्लीट जो कंपनी का डेटाबेस होता है ना, उसमें नहीं होता है। आपके पीसी में आपका एक नाम है और एक होगा एडमिनिस्ट्रेटर या फिर एडमिन, या फिर आपने जो खुद से एक लोकल अकाउंट बनाया होगा शायद आपके किसी फैमिली मेंबर के लिए, तो वो वाला नहीं होगा। तो उस केस में जब वो अकाउंट कोई एक्टिविटी करता है, तो मान लो कि आपने एक अकाउंट बनाया हुआ है आपके भाई के लिए, और वो जब आते हैं और आप मान लो आपसे कोई सॉफ्टवेयर कंपनी सॉफ्टवेयर ओपन रहा, उसने शायद वो उस पे क्लिक किया या फिर वो ऐसी साइट पे गया जिसे वहां जाना नहीं था, तो उसे एक अलर्ट रेज होता है कि दिस साइट वाज विजिटेड या फिर दिस एप्लीकेशन में दिस कमांड वाज एग्जीक्यूटेड। तो इस केस में आता है कि नाउ वी चेक दी अकाउंट। अब ये हुआ कि ये अकाउंट तो कहीं पे है ही नहीं, डेटाबेस में है ही नहीं,
Yes,
तो ये
yes.
अकाउंट आया कहाँ से? कौन सा है, फिर लोकल डायरेक्टरी चेक होगी कि ये तो अच्छा लोकल अकाउंट है, सो हु वाज यूजिंग इट, कब यूज कर रहे थे, क्या यूज किए थे, क्या एक्सेस किया था। अच्छा इस अकाउंट को वो एक्सेस है, बट वो मेन अकाउंट को है, जो आपका अकाउंट है, अतुल अकाउंट है, उसको है एक्सेस, तो लोकल दूसरा अकाउंट कर रहा था, तो ये क्यों हुआ, कैसे पॉसिबल है। फिर इन्वेस्टिगेशन होने के बाद एक बार यूजर से भी बात कर ली जाती है, आपसे बात करेंगे कि एक्चुअल सीन क्या
But
था। तो
then
इस
this
केसेस
is only possible when like I'm using my own laptop, but not a company laptop, right? Or terminal.
लेकिन आप रिसोर्सेज तो कंपनी के यूज कर रहे हैं ना, तो आप अपना यूज कीजिए या फिर कंपनी का लैपटॉप कीजिए, कोई भी यूज
हाँ
कीजिए।
नहीं, नहीं
आप वो
कंपनी के लैपटॉप पे तो लाइक मेरा भाई या कोई लॉग इन
रिस्ट्रिक्टेड
नहीं
ही
कर
होगा।
सकता। हाँ,
करेक्ट।
like it is
हाँ।
my own laptop where I may have my brother's account or someone and he has logged in and then he got the access and then he is trying to do something, right?
ओके, तो इस केस में कैसा है, देर आर थर्ड पार्टी नहीं, माइक्रोसॉफ्ट का ही इंट्यून मैनेजर होता है, तो
Hmm.
जहाँ पे पर्सनल डिवाइसेस रजिस्टर्ड किए जाते हैं कि
Okay.
आप इस पीसी को यूज करेंगे एक्सेस करने के लिए। तो इस केसेस में उस मैनेजर में दिखता है कि कौन से अकाउंट्स है, क्या है, नहीं है। और अगर नहीं भी होगा तो भी आप जो रिसोर्सेस एक्सेस करेंगे उसमें वो यूजर आईडी, यूजर कैप्चर होता है। सो
Okay.
अगर अब दिस इज रियली एक्सट्रीमली ए केस की दैट पर्सन यूजेस योर अकाउंट टू एक्सेस, उस केस में तो
Hmm.
बहुत मुश्किल हो जाता है, फिर तो पैटर्न चेक करना पड़ता है कि
Hmm.
आपने 30 दिन से ये सब एक्सेस किया था, लेकिन आज अचानक से आपने यूट्यूब कैसे एक्सेस कर लिया। ठीक है, कि
Hmm.
मतलब वो आपके आपका भाई आपके पीसी पे बैठा है, आप ही का नाम यूज करके, आप ही का आईडी यूज करके ये कर रहे हैं। अदरवाइज वो कैप्चर हो जाता है जब वो इंसान यूट्यूब पे या फेसबुक पे जाता है, वो एक्सेस करता है ना लिंक, तब वहां पे आ जाता है कि यूजर ब्रदर वन एक्सेस्ड सो एंड सो। तो इस केस में इमीडिएटली पता चल जाता है कि आप नहीं, कोई और आपका पीसी लॉग इन करके यूज कर रहा है।
Okay. Got it.
ऐसे।
Thank you.
हाँ, वो जो आपके पीपीटी में एसआईएम टूल था ना लास्ट में,
Mm-hmm. Oh, that is
हाँ, वो
the tool.
एसआईएम टूल ये सब कैप्चर करता है।
Okay.
तो अब इंडस्ट्री में अब एसआईएम टूल बहुत सारे हैं। एक तो माइक्रोसॉफ्ट सेंटिनल है, ठीक है,
Mm-hmm.
फिर ये क्राउड स्ट्राइक
Splunk
तो है ही,
Splunk
फिर
हो गया, आर्केसाइट हो गया, लोगरिथम हो गया, आर्केसाइट, स्प्लंक,
हाँ
लोगरिथम।
स्प्लंक, स्प्लंक एक सेकंड हाईएस्ट एकदम।
तो उसमें
तो
क्या होगा,
ऐसे काफी
कोरिलेशन
सारे जो
टूल्स।
तुम्हारे लिए वो इंफॉर्मेशन कैप्चर कर लेते हैं।
Okay. Okay. Thank you.
नो प्रॉब्लम। services are prone to denial of service attacks, again the same thing कि जो अटैक मैंने बताया वो कैसे होता है। I think I missed this point. A client server network is very decisive. Sometimes regular computer hardware does not serve a certain number of clients. In such situations, specific hardware is required at the server side to complete the work. इसका बेस्ट एग्जांपल है अपना ये आपने कभी कॉम्पिटिटिव एग्जाम्स दी होगी, तो उसमें वो कहता है कि मुझे क्रोम का वर्जन 10.7.9 ही चाहिए।
Yes.
तो इस केस में क्या होता है कि क्रोम आपका क्लाइंट है, ये PC1 इस पे है क्रोम, वो कहता है कि मुझे ये कॉम्पिटिटिव एग्जाम देनी है तो मुझे ज्वाइन करना है।
Hmm.
लेकिन सर्वर से इसकी नहीं, माय हार्डवेयर and my software do not cater to Chrome 10.7.1.
Hmm.
It will only accept requests and serve requests that are Chrome 10.7.9 and
Right.
above.
Hmm.
तो इस केस में आपके पास तो बहुत डिसाइसिव हो जाता है वो सर्वर कि
Hmm.
एक तरह का हार्डवेयर ही चाहिए, एक तरह का सॉफ्टवेयर ही चाहिए, सब कुछ सब स्पेसिफिक चाहिए। तो उस केस में फिर वो जो एक्सेप्ट करता है उसकी जो कैपेसिटी है वो कम हो जाती है, उसका पूरा पूरा यूज नहीं होता। अगर उसकी कैपेसिटी 1000 क्लाइंट्स, लेकिन आधे लोग जो कनेक्ट कर रहे हैं उनका सर्वर है ही नहीं, तो वो कैसे इंडस्ट्री व्यू के हिसाब से अननेसेसरीली उसकी पावर यूज ही नहीं होती। यू आर पेइंग फॉर समथिंग दैट यू आर नॉट यूजिंग फुल्ली। उसके ऊपर क्लाइंट का भी प्रॉब्लम होता है कि उनको वो सर्विस नहीं मिल रही है जिसके लिए यू नो दे हैव पेड फॉर, या फिर जो सर्विस उन्हें चाहिए। अब एग्जाम नहीं हो रही है तो बहुत बड़ी बात है, फिर उन्हें भी अपना अपडेट करो, इसके हिसाब से मेंटेन करो, तो ये सारी प्रॉब्लम्स होती है। इसीलिए इस सर्वर का हार्डवेयर और सॉफ्टवेयर बहुत डिसाइसिव हो जाता है इस केस में। तो ये एक इसका डिसएडवांटेजेस है। तो इस केस में कैसे होता है ना, कंपनीज कभी कभी ये वर्ड सुना होगा, लेगेसी सॉफ्टवेयर, लेगेसी हार्डवेयर, वो मेंटेन
Yeah.
रखती है। हाँ, तो उसको कभी अपग्रेड नहीं करती, वो वैसे ही रखती है ताकि पुराने क्लाइंट्स को भी सर्व कर सकें और जो नए हैं उनको भी सर्व कर सकें, ऐसे करती है। तो ये एक थोड़ा आउटडेटेड क्या बोलते हैं, एक जुगाड़ है ये टू वर्क विद स्टफ, क्योंकि सब not everyone can be on the same version, same hardware and same software, ठीक है। तो इस केस में अनदर वे कि आप क्लाइंट सर्वर आर्किटेक्चर में डेडिकेटेड सर्वर ना रख के कोई पीसी या कोई ऐसा सर्वर रखे जो खुद रिक्वेस्ट भी कर सके, यू नो, इन दिस केस कि मैं आप ही के रिसोर्सेज यूज कर लेता हूं और आप क्रोम यूज कर लो, चलेगा, मैं एडजस्ट कर लूंगा उस हिसाब से।
तो इस चीज में सिट्रिक्स सर्वर कम इनटू पिक्चर, राइट? तो वहां जाके मैं आई कैन एक्सेस व्हाटएवर इज रिक्वायर्ड, राइट? आई वुड बी अ डम
हाँ,
टर्मिनल and then I would be logging to Citrix and get the things done.
yes, Citrix ऐसे ही होता है। सो ये सब मेंटेन्ड लेगेसी या फिर जो क्या कहते हैं कंपनी के पास पहले से मेंटेन किए हुए और ऐसे पुराने सिचुएशंस में वर्क करने के लिए जो सॉफ्टवेयर और हार्डवेयर मेंटेन होता है ना, वो सिट्रिक्स में मिल जाएगा।
Okay.
डेमो, एक सेकेंड। तो डेमो के लिए आई एम यूजिंग ये यूडीपी एको सर्वर एग्जाम्पल, ठीक है। इसमें क्लाइंट होगा, सर्वर होगा, एंड द ओनली थिंग इज गोना डू इज एस्टैब्लिश अ कनेक्शन, ठीक है। इस केस में क्या है, सर्वर कंटिन्यूसली नेटवर्क को सुन रहा है, मैं एक कनेक्शन रिक्वेस्ट भेजता हूं कि ऑल आई वांट टू डू इज कनेक्ट विद दिस सर्वर, ठीक है। और जैसे ही मैं इस सर्वर को कनेक्ट करता हूं, सर्वर कोई मैसेज भेजता है मुझे, लाइक फॉर एग्जांपल कि कनेक्टेड, ठीक है, या फिर थैंक यू फॉर कनेक्टिंग, जो भी है, ठीक है। ये वो सर्वर मुझे वापस भेजेगा, दैट इज ऑल आई एम गोना डू, ठीक है। और यूडीपी को सर्वर, क्योंकि आई एम यूजिंग यूडीपी प्रोटोकॉल, ठीक है, टीसीपी नहीं यूज कर रहा हूँ, यूडीपी प्रोटोकॉल यूज कर रहा हूँ। टीसीपी और यूडीपी में फर्क पता है, एक बेसिक मेन डिफरेंस।
So TCP always acknowledge, UDP doesn't acknowledge. So it's like even if there is packet gaps or it doesn't care about it.
करेक्ट, एब्सोल्युटली करेक्ट। तो अगर टीसीपी होता तो मुझे ये कनेक्टिंग का पूरा पूरा मैसेज आता ही 100% आता। अगर यूडीपी है, ठीक है, और कुछ प्रॉब्लम हो गया कनेक्शन में, तो मुझे शायद सी के बाद डायरेक्ट टिंग ही आएगा, ये बीच का सब गायब हो जाएगा, क्योंकि इसका कोई एक्नॉलेजमेंट नहीं है, ना कोई सिस्टम मैकेनिज्म है कि मुझे ये मिलेगा कि नहीं। सो टीसीपी में ये पूरा का पूरा वर्ड आएगा ही फॉर श्योर, लेकिन यूडीपी में नॉट नेसेसरीली ये आएगा। हम जो अभी टीम्स पे है, वो यूडीपी यूज कर रहा है, ये कॉल ये यूडीपी यूज कर रहा है कि टीसीपी?
It's UDP because like most of the thing, if even there is a low bandwidth network or something, we can't get anything what has happened earlier, right?
Correct. Not whatever I'm saying has to is reaching you. So if there is some connection problem and you miss out, there is no way to get unless मेरी तरफ से मैं खुद फिर से उस बात को बोलता हूँ।
Yeah, or else later we can go and again see the recording.
Yes. Yeah, that is also. So वही है, बस ये बेसिक है कि I establish मैं कि I want to connect. He says, okay, you are connected. Thank you. That is the basic UDP client server एग्जाम्पल. ठीक है, इसमें चाहिए तो आप प्रोसेसिंग भी कर सकते हो कि मैं यहाँ पे जो स्टार्टिंग का फंक्शन है वो सिर्फ इसके लिए कि वो एक्सेप्ट करे कनेक्शन. जो सेकंड फंक्शन है मैं उसमें लिखता हूँ एड ए प्लस बी. ठीक है, ये मेरा फंक्शन हो गया. और इसमें क्लाइंट में मैं उसको दो नंबर्स दूंगा, ए और बी. ठीक है, आई गिव हिम नंबर्स. ये जो सर्वर है वो उसको ऐड करेगा और मुझे आंसर देगा. ठीक है, आई कैन डू फंक्शनिंग ऑल्सो, बट फॉर डेमो पर्पसेस आई एम जस्ट एस्टेब्लिशिंग अ कनेक्शन. यू कैन डू अ लॉट मोर विद दिस आर्किटेक्चर. आप पूरी की पूरी वेबसाइट क्रिएट कर सकते हो या फिर एक सिंपल ऐड फंक्शन ऐड कर सकते हो. ठीक है, आई थिंक टाइम इज अप. सो आई मीन बिफोर वी गो, कोई एक शॉर्ट में समराइज कर सकते हैं कि what we saw, anything particular. Please add if you have anything additional information कि आपने आपके particular cases में experiment करते वक्त, job में या फिर सीखते वक्त कुछ अगर सीखा हो, कुछ additional information हो, please discuss. This will help us all to gain knowledge. Like Atul, like thank you for your question. This is going to help me and everyone a lot.